report. So I've downloaded this dataset from Kaggle, and it has so many columns. You can see from age, and I'm not so much a health expert, but imagine you're provided with this dataset, and one of the key things you have to do is to try and get results out of it. Someone maybe wants you to look at the target variable, that's the death event. What are the probable causes? And these are the different columns they have given you. Age, maybe the patients have anemia. These are the factors that are a bit so technical. How best would you do or deal with this? So one of the key things I really like to do is one, first do profiling of data. So data profiling is where you're trying to understand how your data is distributed. Is it clean? Does it have issues? Um, and are there missing values? What are the duplicates? What are the correlation between the variables? Usually referred to as features within a data set. And then if there are issues, you're able to target those main issues in your data cleaning and extraction. So let's do some data profiling just for this case. So I'm going to use Google Colab, and uh, you can always use any tool, some create environments, so there are copies and all that, but this is a simple demo. I'll just use a Google Colab as and upload into the temporary file the CSV. So then usually I would always encourage that you use pandas. So then there are so many packages that do explorative analysis, but I always prefer to use the Y data profiling. And so once you've finished importing these, yes, we haven't installed. So we need to install this package in your environment just by running that command. Once it has finished installing, you can then import straight the profile report. So we are going to just use these two. There are so many other things with these that packages established there. You can even write your own functions and using both NumPy and pandas. But for this demo, we're going to use profile report. So the next thing is we need to read the data. So I'm going to read the data at failure dataset is equal to pd dot csv. So copy its path. So I've read my data, and then do some EDA, explorative data analysis. So the report is going to be to profile our data set. So once we've finished profiling our data set, we need to go ahead and generate its HTML. So it's going to generate for us an HTML so that we try to understand these variables. Usually it's hard to understand the variables by yourself when a report is big, but then This tends to summarize everything for you in just minutes. You're able to tell how your report is there. So let's have a look at our report. So yes, you can see our report shows that from our data here, we have 13 variables, of which 7 are numerical and 6 categorical. The observations are 5,000. Those are equal to the rows. The missing cells are not there. This is really good. There are those duplicate rows, and the percentage just holds 9% of our records, and the total size in memory. However, it highlights the corrections. The duplicate rows, you can go straight to them and see them. These are repeating. So most of our entries, that means we have high entries around the age bracket, 431 entries around the age bracket of 82 having the same properties. This could show us that maybe our data is having issue. So this is 33 duplicates. Uh, it could be having issues, or perhaps the people with actually this kind of observations. So my key factor always to look out for is the correlation event. So there is a high correlation between the death event with time. So time is highly correlated with death event. For purposes, this data set time is mainly um, a factor that we look at around treatment. You get it? So we can go there to see how these uh, are related, correlation here. So you can see that from our figures, time and death are in opposite correlation and they're highly correlated. So meaning the moment someone is highly on treatment, the less likely they are likely able to to die. So let's go and look at our correlation. You can see time and death. It's extreme, negative 0.